video, I'd like to talk to you about the two main kinds of networks. We can basically group networks and network analysis into two major groups. So let's talk about that right here. The first major kind of network in network analysis is called a transportation network. Transportation networks. And this is the kind that you're using when you are using Google Maps. So when you think about transportation networks, a great example of these are Google Maps. Not the only example, of course, and you can set up your own inside your own GIS software, but Google Maps does definitely use transportation networks for its service. So what are some of the characteristics of transportation networks? They have few constraints on travel. As in, what direction you can go, what direction you can travel along edges, what turns you can make along junctions. This actually doesn't mean that that has no constraints on travel, because there are, for instance, in a few cases, one-way roads, junctions. When you get to an intersection, sometimes you cannot turn in one particular direction. But by and large, transportation networks have very few constraints on travel. You can enter the network at most any point. You can also exit the network at most any point. Again, you may not be able to enter it and exit it at all points, but for the most part, when you're thinking about a transportation network and you're thinking about how to route yourself from one point to another, maybe your house to your friend's house or your house to some office building, well, you can enter the road network most anywhere. There are driveways and so forth that go up to all these different buildings and all these different houses. For the most part, where you are, you're going to be able to enter the network, and then for the most part, you are also going to be able to exit the road network when you want to be off of the road network. This is not always the case. It's not 100% the case, because we can think of a few parts of the network where we can only enter it at certain points. For instance, the interstate system, you can't just enter the interstate system wherever you want. There are specific junctions, specific locations where you have to be in order to enter the interstate network, and then certain places where you have to be in order to exit the interstate itself. That's part of what makes the interstate such an efficient system. You don't have people just entering and exiting and leaving the interstate and trying to merge onto the interstate anywhere. You do this at defined locations, and then you get onto the interstate network and are able to travel quickly for long distances. So there are a few exceptions like that, but still, by and large, these are the characteristics of our transportation networks. You can basically go anywhere from any point. I'll put that down here. Get anywhere from anywhere. There's that old joke about being lost and then going to a convenience store to ask for directions, and then you tell the clerk, well, I'm trying to get to wherever it is you're trying to get. Can I get some directions? And then the answer is, oh, you can't get there from here? Well, of course, at the risk of explaining a joke, of course that's funny, because for the most part, because it is a transportation network, when you're talking about the road systems, we should really be able to get to just about any point from any point. But that's not the case with other kinds of networks. So these are the kinds of networks that we are probably most familiar with, and we work with most of the time when we're working with something like Google Maps. But it is only one of the two major kinds of networks. So let's contrast this with something called a utility network. A utility network. And I don't have a great example of a utility network to just look up online for that is commonly in use, because these are often created for more specialized purposes. But when you're talking about a utility network, you're talking about the network which enables something like water or gas or oil or electricity to go from one location to another. So we can think of all different kinds, when you're thinking like that, all different kinds of services, all different things that are delivered according to a network, but that has very different characteristics than the transportation network. They're utility networks. So, characteristic of utility network is that they are highly directional. As opposed to transportation networks which have very few constraints on travel, a utility network is highly directional. Because if I've got, if this is some kind of network that is showing me water pipes going from the water treatment plant to somebody's house, well, it's not true that there are very few constraints on the travel along these pipes. These pipes actually are highly constrained. You know, when the direction along these edges is highly constrained. When water leaves this water treatment plant, it's going in this direction. You know, water doesn't flow back toward the plant. No, water is flowing out from the plant along the pipes, you know, and then in this direction along this pipe, and this direction, and this direction, and this direction, and then this direction out to the house. Water doesn't flow from the house back to the water treatment plant. So there's a definite direction to the flow, and so when you're talking about a utility network, every edge has the direction that whatever it is that is flowing along that edge must travel in. And then when you encounter junctions, the junctions will specify which are valid turns to make and which are not. So very highly directional, many constraints on the travel. Entry to network is specified. There are only certain locations where you can enter this network. If you're talking about water here again, the only place that you can enter the network is here at the water treatment plant. Or maybe if there are a couple of them, then you could enter it there as well. But importantly, unlike the road system, where if you live over here, you can just enter the road system here, you can't do that with a utility network. There are defined entry points for, in this case, the water or the power or the oil into the utility network. Likewise, exit points are established. Where can water leave? Well, the water can't leave this network wherever it wants. There have to be defined places that have to be just deliberately set up in order to remove water from the network, such as different houses or office buildings. So the exit points are established as well. So I guess to sort of round up our comparison here, you can't, with utility networks, that joke, oh, you can't get there from here, isn't valid, because there may be certain places you can't get on a utility network. Can't get to certain places. If I am here, if I'm talking about some water that is here, there are only certain places that it can get, which are places that are further down the network that it's flowing to. There's no way for it to go from here all the way back to the source. And so that may certainly be important if some kind of contaminant or some kind of pollutant is being introduced into the utility network here. Well, where can that pollutant get? Well, it can't get everywhere on the network. You know, it's going in one direction, because it's going down with the flow of the edges. So there may certainly be places in utility networks that you cannot get from certain points. Let me give you two quick terms here that are related to utility networks that we've already talked about in concept, but let me go ahead and give you these terms that we use a lot in utility networks. The first of these is source. So what is a source? This is something that adds material, whatever that is, stuff, whatever we're talking about routing here, to the network. So if you're talking about your water network and you've got the water treatment plant, that's where the water is being added to the network. And in effect, it acts as a push. You can think of that source, all of the sources, pushing the material in the network away from it, because we've got this highly directional flow The flow is flowing away from the sources. The material comes in at the source and flows away from it. Where does the material flow to? Well, it flows toward sinks. And sinks use or remove material, whatever it is, from the network. You can think of sinks drawing the material toward themselves. Sinks draw the material, whatever's in the network, toward themselves. So if you look at homes or office buildings, when you're talking about a water network or the power grid, the sinks are everybody's house, everybody's buildings. They're drawing power, water to them, and then removing it, using it from the network. So as far as directionality goes, we're flowing away from sources and toward sinks. If you set up sources and sinks in your GIS and you add that to your data set, you can begin to automatically generate your directions of flow. A computer can do that for you if you specifically tell it, now here are the sources, here are the sinks, and then you're setting up this utility network, and it will be able to sort of judge, okay, well then how would that material in the network flow from the sources to the sinks? So you can begin to automate that, but sort of as it is with all of these things, if you automate the creation, you may be missing a lot. So, maybe the automated creation of this based just on sources and sinks are the first step, but then you go back and you revise your network and you create your data set so that it's much more explicit about the directionality of every edge and every junction, and it much more accurately represents the thing that you are trying to model. But sources and sinks are very important terms to remember when you're doing utility networks. So these are our major two different kinds of networks, and we deal with them both in GIS. Let me give you a couple of examples of the kinds of problems that you might solve, or the kinds of questions that you might use each one of these different networks to answer. When we're talking about using Google Maps and a transportation network, we are talking or typically used to solving or asking it just a couple of different questions, which, basically, maybe just one: how do I get from A to B? And then there may be a couple of different options there. Maybe you want shortest path, or shortest distance. Let me put that over here, shortest distance. Or you might want least time, and I think that you should be able to take a look at that in Google Maps. But on the whole, if you branch out from transportation networks just on Google Maps to the kinds of questions that people solve when they have their own transportation network set up, delivery is something that you can optimize and make very efficient using a transportation network. Let's say you've got 16 different locations that you need to deliver some item to. What is the best way, what is the most optimum way to go about delivering to all of those locations? So this is sort of to optimize delivery patterns. You can also take a look at travel time, for travel time around a particular location. So what is maybe the fire service area? Maybe we want the fire stations to be able to respond to everything, any fire within the city within 10 minutes, let's say. So we're going to need to place fire departments around the city so they can get to everywhere in the city within 10 minutes. Well, how do they know? They're going to run this transportation analysis because it has to be done along the network. The fire engines have to travel along a network. And so we're not talking about just straight line distance from the fire departments to everywhere else in the city. You're talking about the amount of time that they can spend traveling along a network. So maybe fire service areas in a city. and we're going to compute that time along a network. Those are just some examples here, but these are very important questions that you may want to ask, and there are others that you can ask besides. But Google Maps isn't going to help you solve these kinds of problems. If you have these kinds of questions, you have these kinds of problems, then you're probably going to need to establish your own transportation data set inside a GIS that's going to allow you to customize it and ask custom questions. And of course, this is something that a lot of people do. I mean, optimization of delivery patterns. I mean, the Post Office, Federal Express, UPS, all of them are huge on optimizing things like delivery patterns. The traveling salesman problem. Oh, let me just put that down here because that's something that we should at least know the name of. Traveling. That one is related to the delivery problems, but if you are a salesman and you're trying to get to all of these locations and you're starting out at point X and then you've got to go and most efficiently make all of these visits and then also return back to point X. You got to get back to where you started from at the end of the day. What's the best way to do that? Well, you can find that out with a network analysis on a transportation network. With a utility network, you're sort of asking different problems. So if there's a problem, like if you're talking about water lines, if there's a pipe or valve failure, which customers are affected? If you're talking about some kind of electrical network, what happens if a transformer blows? Which customers are affected by that? You would be able to tell that through the utility network analysis. How can water be rerouted if a pipe needs repair? You can also go backwards. If you are looking at this, and maybe this is our water network or our power network, and you have customers that are calling in to say that all of a sudden they don't have water or they don't have power or something like that. Well, what you do is you start, you ask them, okay, what's your address? And then you start geocoding the addresses that come in. And so you go, okay, I've got these two people who called in who said they don't have water or power. Could the problem be here? Okay, but then this person calls in and go, okay, well now it can't be here. It's got to be further up this network because this person called in here. And then, this person calls in, and then this person calls in over here, and you start to get these people calling in, and you identify that, oh, but nobody calls in from over here, so we must have a problem here at this juncture. And that's how they can quickly start to identify what the likely location is for some kind of break in the network based on geocoding addresses that come in, and then looking along the network. And of course, you can do this in an automated way, and coming up with what where the break in the network must be to send out a repair team for it. And then I also said something like, how does a contaminant spread through the network? If something gets into the water supply at this point, who's going to be affected and who's not? That's just a small sample, that's just a small taste of the kinds of questions you can ask with network analysis. It's a very interesting field. There are all kinds of questions you can answer using network analysis, especially when you've got this exposure to both the transportation and utility network analysis. It's a huge field to get into, and network analysis is even broader than just transportation and utility networks in a GIS. Lots of people study network analysis in other fields as well, whether you're talking about connectivity of friends in social media circles or even the connections in the brain. There's a lot when you're talking about edges and junctions in general that you can do. It's a huge field. But all right, we will take a look at how the computer solves travel problems. We won't look at all of these, we don't have time. But I do want to take a look at how the computer solves problems like this, because this is the one that we're exposed to on Google Maps. So let's take a look at how a computer goes about solving these kinds of questions about getting distances from A to B.